All right, so for our next lesson, we are still working with angle measures, but we are going to be doing applications of angle measures. So it says here, on our previous lesson, we learned the radian measure of an angle theta is the number of radius units in the arc length s. So theta is equal to the arc length over the radius. So this is a formula that we're going to be following, okay? That we need to keep handy here. So theta equals s over r, which s stands for your arc length. Whoops, what did I do? And the r stands for your radius, okay, which is this part right here. Alrighty, so here they want us to find the measure of angle theta in radians and degrees. So here I'm going to use my formula. Theta is equal to S over R. Alright, so then from there, if we look, our S, which is our arc length, they show us here is this piece right here, and they have it labeled as 10 meters. So on the top, I'm going to put 10. And then on the bottom is our radius, which is here, and that's the 2. So then on here, theta equals S over R equals 10 over 2, which is just 5. Okay, so 5 radians is this angle here. Now they do want us to change it into degrees. So to change it into degrees, we're going to have to take the 5 and we multiply it times 180 over pi. Okay, this is from yesterday's lesson. We had the little formulas there. So I'm going to go ahead and do that in my calculator. 5 times 180. Whoops. That gives me 900, and then we take the 900 and we divide it by pi. And that gives me 286. So this is going to round to 286 degrees. Okay. The next one says any circle with a radius of 7.4. So here, they already give us the r. Our radius is 7.4, so I'm going to go ahead and put r equals 7.4. And an angle intercepts an arc length of 36.6. So that means that S is equal to 36.6. Find the angle in radians to the nearest 10. Okay, so that's all they're asking us for. So we use the formula theta is equal to S over R. Now we know that S is equal to 36.6. And then our radius here is equal to 7.4. All right, so then if I go ahead and put that in my calculator, 36.6 divided by 7.4, that gives me 4.94. And they want us to round to the nearest 10, so it's just going to be 4.9 radians. All right, the next one says any circle with a radius of 6, so in this case, r is equal to 6. And an angle intercepts an arc length of 12 pi. I don't know why this came out like that. 12 pi. So S is equal to 12 pi. Find the angle in radians in simplest form. Okay, so our angle theta is equal to S over R. So S over R. Okay, now they tell us that S is 12 pi. And then R is 6. So 12 divided by 6 is going to give me 2 pi. All right, so now what if we're going theta equals S over R? Okay, so for the arc length, S yields a formula to find the length of the arc of a circle. Then we're going to use a different formula. So pretty much what they do here, we have theta equals S over R, but they want the arc length, they want the S. So we multiply both sides by R to get the S by itself. And then that's how you come up with this formula here, S equals theta times R. Okay. So here it says find the arc length of each arc. So remember from the formula, it's going to be S equals theta times R. Okay. Theta is our angle measure. So in this case right here, our angle measure is 3 pi over 2. So I'm going to go ahead and plug it in now. 3 pi over 2. R stands for our radius. So here my radius is 16, so times 16. And we're looking for the arc length S. Okay, so I'm going to go ahead and simplify this. So S is equal to 3 times 16. So let me see back. 3 times 16 divided by 2. That is going to give me 24. So this would give us 24 pi. Okay. This is if they want it in terms of pi. If they ask you for your answer, and then it's going to be feet because it's an arc length. If they ask you for the answer as a decimal, I'm going to go ahead and take 24 and multiply it times pi. That gives me 75.39, so 75.4. So the arc length, which is the distance from here to here, would be 75.4 pi. 75.4 feet. Okay, now looking at the next one. Now this one, they give us the angle in degrees. Now we do not want the answer in degrees because that's not how the formula was made. It was not made to be plugged in as degrees. So we do have to change that to radians. So I'm going to go ahead and take 315 and multiply it times pi over 180. So 315 divided by 180. Okay, remember, since we're leaving it in terms of pi, we have to not put the pi. Okay, so 1.75 changes into 7 pi over 4. And then we ourselves go ahead and just put the pi back in there. All right, so then from there we have our angle, which is theta. So 7 pi over 4. We're going to multiply that times our radius. Our radius here is 11 feet. And this is going to give us our arc length S, because remember S equals theta times R. So then here I'm going to do 7 times 11 divided by 4. So 7 times, 7, darn it, backspace, 7 times 11 divided by 4. That gives me 19.25. Ooh, let's get that as a fraction. Function. Let's get that as a fraction. That's going to be 77 over 4. So if they want it in simplest form, it would be 77 pi over 4. If they don't want it like that and they want it as a decimal, that gives us 19.25. And then we still have to, we take the answer and we multiply it times pi. That gives me 60.47, so 60.5. Our units are feet. Okay, so here it says in a circle with a radius of 9.5, so here our R is 9.5, and an angle measuring 3.7, so then theta is equal to 3.7. It is in radians, so we have to do no conversions here. Find the length of the arc. So S equals, and we're rounding to the nearest 10. So S equals theta times R. So theta times R. Okay, we know that theta is 3.7, and we know that R is 9.5. So our arc length S is equal to 3.7 times 9.5. 3.7 times 9.5. Enter, that gives me 35.15. So S equals 35.15. And it'll give us the units. All right, so here the next one, it says, in a circle with a radius of 33, so R is 33, and an angle measuring pi over 4 radians. So theta equals pi over 4. All right, they want us to find the arc length, so S. Remember, S equals theta times R, where theta is equal to pi over 4, and R is equal to 33. So this one, they are asking for it in simplest form. So when we do this, we're going to go ahead and do 33 over 4, which isn't going to reduce. It's going to stay as 33 pi over 4. All right, so now what if we're solving for the radius? So if we're solving for the radius, we take the same formula. which is theta equals S over R. And the way that they do this is they pretty much put this over 1 and cross multiply. So we get theta times R equals S, and then we divide both sides by theta to solve for R. And we get R equals S over theta, okay, which is what they got here. That's our new formula. So any circle and angle measuring 2.2 radians intercepts an arc of, so this is our angle, 2.2 rad, so theta equals 2.2. Intercepts an arc length of 34.9, so S is equal to 34.9. Find the radius of the circle. So R is equal to S, which is 34.9, divided by theta, which is 2.2. So I'm going to go ahead and substitute those numbers. They do want us to round to the nearest tenth. So when I put that in my calculator, 34.9 divided by 2.2, that gives me 15.9. R equals 15.9. Okay, the next one, it says in a circle an angle measuring 5 pi over 4 radians. So that means that our theta is equal to 5 pi over 4 and intercepts an arc length of 5 pi. So R is equal to 5 pi. Find the radius of the circle in simplest form. Wait, this is S, I'm sorry. S. Should have been in blue. Okay. So here our radius is equal to our arc length, which is 5 pi, divided by our angle, which is 5 pi over 4. Okay. So then from here, I'm going to show you guys how to divide fractions. So here, the top part, I'm going to put it 5 pi over 1. So we have to make them both look like fractions. And on the bottom, we have 5 pi over 4. So when you take a fraction and divide it by another fraction, what we're going to do is we're going to multiply the outside ones. So 5 pi times 4 gives me 20 pi. Oh, I'm running out of space. And then on the bottom, we multiply the inside numbers. So 1 times 5 pi is 5 pi. So in this case, the pi's cancel out, and 20 divided by 5 gives us 4. So that means the radius is 4. All right, this next one, area of a sector. So to find the area of a sector, we are going to have theta. Look at this little note. It does tell you that theta needs to be measured in radians. And then you're going to also need the radius. Okay, so if you're just looking for the area of this little section right here, you can use this formula. Okay, so area equals 1/2 our radius squared times our angle theta. Okay, so if we look here, my radius is going to be 14, so we're going to do 14 squared. And then my angle is 17 pi over 12. So area equals 1/2 times 14 squared times 17 pi over 12. So I'm going to go ahead and put that in my calculator. So 1/2 times 14 squared times, make my fraction. On the top, I have 17 pi. On the bottom, I have 4. I press enter. That gives me area equals, it doesn't tell me to give it into radians or degrees, so I'm just going to leave it like that. 1308.7. And our units are yards, and then area squared. Okay, this next one, remember, our formulas are not made to be with degrees, so I do need to change that to radians. So we multiply it times pi over 180. And then if I put in my calculator, 150 divided by 180, enter. That gives me a weird number, so I'm going to have to change that into a fraction, and it gives me 5 over 6. So it's going to give me 5 pi over 6. Okay, so I'm ready to use my formula. It's area equals 1/2. My radius in this case is 3, so 3 squared times 5 pi over 6. So 5 pi over 6. Okay, so I'm just gonna put all this in my calculator. We have 1/2 times 3 squared times 5 pi over 6. That gives me 11.78, so that would be 11.9. So my area is equal to 11.9. My units are meters squared. Okay, so a few more. Here it says in a circle Q with PQR, angle PQR is 76, PQ equals 4 units. Find the area of the sector PQR, round to the nearest hundredth. So I'm going to make a circle. Now it's circle Q, so the Q goes here in the middle. So that means this is PQR. P, Q, and R. This is the angle. Okay. They tell us that this angle is 76 degrees. So remember, we can't use 76. Let me go ahead and change it to pi over 180. We have to change it to radians. So 76 divided by 180. Let's get that as a fraction. That gives us 19 over 45. So this is 19 pi over 45. Okay, and then PQ is equal to 4. So from P to Q is equal to 4. Well, that is our radius. Okay, so now that we have our angle theta, this is going to be area equals 1/2 the radius squared, so 4 squared, times our angle, which is 19 pi over 45. And then they do want us to round to the nearest hundredth, so we're going to round 2 decimal places, just making sure I have the formula right. So then area equals 1/2, so I'm going to go ahead and 1/2 times 4 squared times 19 pi over 45. That gives me 10.6. All right, the next one, I'm going to do the same thing. I'm going to draw my circle. Whoops, I think this was an accident, guys. I kind of messed up these letters. It shouldn't be PQR. But we have circle S, or let's just say this is circle Q like we did on the last problem. So we have circle Q. This is Q in the middle. Our angle is PQR, so this is P, Q, and then this is R. This angle is 70 degrees, but remember we can't use 70, so we're going to have to change it to radians, so pi over 180, which is going to reduce to 7 pi over 18. So then now I have my angle, and then it tells you RS equals 10. Oh man, I really messed this up. It should be RQ, because remember we changed S to Q. So RQ is 10. And so now that we have our radius is 10, we're going to go ahead and plug these in. So my area equals 1/2. My radius is 10, so 10 squared times 7 pi over 18. 7 pi over 18. So we plug that in the calculator, exactly the way we see it. So 1/2 times 10 squared times 7 pi over 18. Enter, that gives me 61.08, so that would round to, oh, we're going to the hundredths, 61.08. This one I didn't round to the hundredths, but it's kind of late for me to go back. But that's it. Thank you guys. Sorry about the typos. We'll see you guys next time. Bye.